Welcome back. In this video, I'm continuing daily Leetcode problem, and for today, that's 959 regions cut by slashes. Okay, let's begin. So, an n times n grid is composed of 1 times 1 squares, where each 1 times 1 square consists of a forward slash, backslash, or blank space. These characters divide the square into continuous regions. Given the grid represented as a string array, return the number of regions. Note that backslash characters are escaped, so it uses two backslashes to represent it. Okay, we have input grid. This is each row. Okay, and we have two regions. So one row, second row, okay, again, two regions. Oh, sorry, one region, because it's continuous. And here we have this, so that's 4 or 5 regions. Okay, I struggled a bit with this problem. And so the solution for it is quite tricky if it's first time you're solving something like this. So the idea is to do this problem similarly as like fill the regions, or I don't know, or islands, how many islands are there or something like that. So the idea is to let's see this example, to transfer this to translate this into problem that we can solve that way. So like in this problem, when we have grid like this, so this, imagine this is occupied, this is occupied, this is occupied, this is occupied. We can see that these regions are actually unoccupied, so they are empty. So we need to like increase the dimensionality of this to succeed it, and we can do it if we increase it by 3. Let me try to show it to you. It will be a bit hard. Okay, I have space. So each so we have 3 types of elements for our input. It's forward slash, backslash, and empty. When it's empty, then we don't fill it like with anything. In a sense, like when we transfer empty like grid position, we don't do anything. But let's examine. So for the forward slash. So forward slash, we need to transfer it. Well, let's first try to transfer it in grid 2 by 2 to see what's the problem here. So I don't know if it's going to look good. So here, and I'm gonna do it like zeros and ones. So if we transfer forward slash in in 2 by 2 region, 2 by 2 grid, so we'll get something like this. And this is okay, but there is a specific problem. Let's also see just what would backslash look like. So backslash would then be something like this. So 0 and 1. Okay, and generally this would work. So in example 1, we would have something like this. So it would be now we see this how it's written. Let me know. So for the example 1, we have first element is empty, so that's 0 0 0 0. Second is forward slash, so 0, 1, 0, 1, 0. And here we have forward slash and then empty. So this is 0, 1, 1, 0, and the rest is zeros. So in this problem, we could like easily fill it because we would go like into this position in new grid, and if it's false, we would then count it, and then all its neighbors, we would fill it with 1. So when we get to the next, it's already filled, so it's 1, so we don't count like 2 times or something. And same here, so we would get correct solution. But if we had something like this, so it will take a bit more writing, but problem is we can go diagonally. How can I construct it? Okay, let's imagine this one was, this would be the best example. So this one was like this. So we had first character was also a line like this. So we would actually have one region here. So imagine this was close, so that's this region. We would have one region here and one region here. But if we have this type of approach, we wouldn't be able to do it like to fill like this region. We would get 3 regions here because all neighbors are occupied already. So we would either need to implement diagonal moving, so this, but then again we would also have problem in this type because we can't go diagonally here if these 2 neighbors are present, because that's the line. So it's kind of problematic. It's not good enough representation, so we need to increase our dimensionality by 1. So this example would then be translated to, so let me remove okay, and let's remove this also so it's easy to see how we scale those. So first one would be translated to this. Second one would be translated again to this. Oh. So 1, 0, 0. We can connect them now. And same here, so it would be 0, 1, 0, 0. And we'll just transfer this like this, 0, 0, 0, 0, 0, 0, 0. Okay, so in this example we can, our approach will work because here, okay, we will mark these as visited. In this region we can go to the neighbors because we have this path, and we can mark all them as visited, and this part also is okay. So transferring to each element of the grid to the 3 times 3 grid is good approach. So let's try to code it up. Let's see constraints. So grid length is equal to, so number of rows and columns is the same, it's the n, and n is between 1 and 30. Okay, we get n by n grid. Okay, so we can take n as the length of grid. And what do we do? First, we need to initialize the new grid. So new grid is equal to false. False will mark that something is not visited. So false times, so this will be one row. One row is of size n, so n times 3, if I'm correct. N times 3, yeah, should be for in range n times 3. So we'll have each row will have, instead of n columns, n times 3 columns, and for each row we need to put 3 new rows in this new grid. Okay, and now we need to input like the elements of the original grid to the new grid. So for let's say row in range, and also for column in range, and so we transfer, if it's forward slash or backslash, I'll do first backslash because it's a bit easier. So if grid of row and column is equal to backslash, then we need new grid element. So row times 3, column times 3 need to be, so this is like 0th element, then middle element, and let's move this a bit here, and so element to the row 2, column 2, this will be equal to true, and the same thing for row. Okay, and if it's forward slash, we need to do, okay, so this row is 3, okay, but we need column plus 2 here. Middle element is the same, and here is 0. So yeah, the last element, the middle element, and the first, okay. So this is true. Now we have our new grid, and now we need to, so what do? We go, so for start row, start column in so we need to, okay, let's do this. Oh. So for SR in range and for SC in range and times 3. So I need to check if n new grid of row C is equal to false, and if so, we'll increase count. So plus equal 1. Initialize it to 0. And is equal to 0. And we need to fill this. Okay. Okay, I can fill it in the function. So return count here, and also let's take directions. Directions is equal to 1 0 0 1 minus 1 0 0 minus 1. Okay, and we define fill as x epsilon. So what do we need to do? First, we're gonna define q. So q is equal to dq. We will append new we'll append new starting point, and we can also make the starting point filled. So x epsilon is equal to true, and while q, so row column is equal to q pop left, and we need to take, so change of row, change of column is equal to need to do it for all these in directions. So the RDC is D. We take new row is row plus D row. New C is C plus DC. Okay, and now we check. So if this neighboring position of the grid is within the limits, so times 3, maybe like this, and the same thing for and so and new grid of number of row, number of column is equal to false, or maybe it's not like this if it's not. So new grid of nr and c is equal to true, and we put it on the queue. So q dot append new row, new column, Okay, that was a lot of writing. I think this should be good. Now let's return. Just return, and in the end we return count. So 40 lines, something like that. Let's try it. Can multiple sequence with non-int of type generator false? This was problem. Okay, yeah. So it's accepted. Let's try to submit it. And yeah, it's good. Okay, so it seems memory-wise it's pretty efficient and runtime is also solid. Let's check the runtime. I need to connect to my power adapter. Okay. So, for the space complexity, it should be so 9 times n squared. So it's again n squared, but that's linear because input is of n squared. Okay, fill will get to all the neighbors. Yeah, should be of size of an input because this will be constant. Let's see if we can analyze. Okay, n squared, yeah. But our input is, then also this would be n squared, yeah, okay. N squared for the both. Because n is like size of an input, but input is n times n actually. Because we can see here in description, we have n times n grid, so it seems, yeah. Not sure if I'm correct about that, but if it's not, correct in the comments. Okay, thank you for following in this one, and see you in the next one.